So I think caffeine's good. I published an article in Scientific American in 2015, and the whole take-home message of the article was that many of the chemicals that are in fruits, vegetables, tea, coffee, plants that are good for our health, the actual reason they're in the plants, the evolutionary reason, is that they are noxious agents, they're toxins, and caffeine's a good example. If you take pure caffeine and put it on your tongue, you wouldn't want to eat it. It's very bitter tasting. And caffeine's a natural pesticide produced by coffee beans and tea leaves. And if you take coffee beans or tea leaves and put them on your counter and put most any food next to it, and there's ants in your house, the ants will avoid the coffee beans and the tea, and they'll go for the other things that don't have the bitter tasting chemicals.
Bulletproof Radio, a state of high performance.
You're listening to Bulletproof Radio with Dave Asprey. Today's cool fact of the day is that there are different ways to kickstart intermittent fasting so it's easier for you. If you don't know about intermittent fasting, this is something I wrote about in the Bulletproof Diet, something I've been doing for a very long time. And basically, you eat the same amount of calories you were going to eat. You just eat them in a smaller eating window each day. Basically, you have just lunch and dinner, skip breakfast, or have just lunch and breakfast, skip dinner. It's pretty straightforward. You want to eat in about 6 or 8 hours. So here are a few different options that are out there for you. One is fasting for 12 hours a day. And there's studies for each of these things. There's another one fasting for 16 hours. And interestingly, in that study, men fasted for 16 hours and women fasted for 14 hours, because this is going to sound really, really bad, but men and women are actually different biologically. I know that's shocking for some of us. However, fasting can be harder on women, and I've seen this over and over since I started the Bulletproof blog, where like the rules are different, and there's a couple really popular posts about why intermittent fasting can be bad for women that I've written over the time. There's also fasting 2 days a week, which is called the 5-2 diet. There's alternate day fasting, where you fast every other day or have limited calories every other day. There's one weekly 24-hour fast known as Eat, Stop, Eat. People just skip an occasional meal. And then there's this OMAD, or the Warrior Diet, which is a 20-hour fasting window with a huge meal at night, steak and whatnot. And you could do the same thing with a huge meal in the morning if you really want to carry around steak, eggs, and whatever else you're eating all day long. But that might have some circadian benefits. So bottom line is 6 meals a day, so your body doesn't go into starvation mode. It is absolute bullshit. And it is a way to feel crappy. And probably stay fat. At least that's what happened to me on something like that. And that's not to say you couldn't do that sometimes, especially if you're working out a lot. But if you want to do that on a regular basis as a regular human being, you might not like the results of that. But the number of processed food snacks you eat may go up dramatically if you do that. Today's guest is the foremost scientific researcher on the topic of intermittent fasting, a guy that I'm really, really excited to talk with because there's so much academic research that goes back quite a while now about what intermittent fasting does, but it's one of these precious pieces of knowledge that hasn't entered our consciousness, where it has been fringe knowledge, and it's just now becoming something that not just biohackers do, but your mom might do. In fact, my mom does do it, and it makes a really big difference. So not only is today's guest a top expert on what intermittent fasting does for you, he's also an expert on what it does for your brain, and he's one of the foremost researchers looking at cellular and molecular mechanisms of neurodegeneration, like Alzheimer's and Parkinson's. If you read my book, Headstrong, I actually referenced some of his work in that book. I'm talking about Dr. Mark Mattson, who's a professor of neuroscience at Johns Hopkins. Welcome to the show, Mark.
Thanks, Dave. I'm looking forward to talking to you. I've followed your Bulletproof website for a long time, and when I can, listen to your podcasts, which are always both informative and entertaining. So I'm looking forward to our discussion.
Wow. Well, thank you. I did not know that until we just got on and you mentioned that. So I'm truly honored because I mean, in addition to the intro I just gave you, I mean, you are chief of the Laboratory of Neuroscience at the National Institute on Aging. At least you were until you just retired last month. So in terms of the anti-aging world that I live in, you're sort of a godfather of that. So the fact you've ever heard the show is like epic. Thank you.
Yeah, well, there's one of the big bottlenecks in getting science translated into the real world is communicating to the public. And there's many scientists that either avoid intentionally or just don't want to bother with taking the time to learn how to communicate with the general public. So, outlets like yours, which really are evidence-based and communicate things in a way people can understand, I think are valued. So, I do, and these podcasts are easy to listen to. I can even be, working on a manuscript while I've got a podcast in the background. So, I do find time to listen.
Okay, that's really cool. I'm going to go there. There are not a lot of people here who can listen to one thing and write another thing. Have you always had that superpower?
I don't know if it's a super. I think it started by, I'm a NPR nerd. So I'll have, and I telework. Even when I was lab chief at NIH, I used to telework 1 and sometimes 2 days a week. And I just have NPR on in the background, and I'd kind of tune in and out. There's certain points when one writes that you can kind of relax a little because you don't have to concentrate so much. And so I've learned to do that.
One of my my buddies, real dynamic guy named Andrew, and I'm not going to drop his last name because I think he kind of likes to hide behind the curtains. But he's I had dinner at his house and wrote about it in Game Changers, and he knows what I'm talking about. Entrepreneur friend. He told me that years ago he started using Bluetooth headphones before they actually had the Bluetooth standard done, and he listened to audiobooks 24 hours a day. Like all the nonfiction stuff, just to learn things. And he just finally said, after 2 years of it, my brain just started learning when I wasn't paying attention. But he had to stop worrying about losing something and just assume some of it's going in. And I haven't gotten to that level yet, but I have been able to listen to one thing and write on my latest book, but not the whole time. Sometimes I would, but the load on my brain felt pretty high. Do you feel more loaded if you listen to a podcast and write a manuscript? I'm fascinated by this. I wasn't going to interview you.
Well, no. So I'll pause or turn off the volume on what I'm listening to when I get to where I have to really think for like 10, 20 minutes straight. Or something.
All right, that's a neat little technique. I think most people listening are going, oh my God, it's possible to write and listen. Anyway, that's a new skill for me. So, all right. You also talked about the difficulty of translating science from academia into public knowledge. And I think some of my scientist friends are a little bit frustrated. They're saying, I've spent my life doing all this crazy work, but no one knows about it. And so they're kind of feeling like I did my part. But you've done something interesting. In academia and for research, there's an index of productivity and citation impact. So your H index is over 200, which in academia means you're super rock star, gold record label. And it's a pretty good number.
And it's based on your total career. So it also means I'm getting old.
Okay, that's a fair point. But you've been cited 150,000 times, or your work has been cited. So you're up there, right? But at the same time, you have 3.5 million TED views on your talk about intermittent fasting. So you've crossed, I'm going to call it crossing the chasm, to butcher that term, into, all right, you can now talk to the public about intermittent fasting and reach large numbers. And you've talked to the academic and nutrition and research and neuroscience world. What was the trick for you as I'm going to call it a hardcore aging neuroscience guy to cross over and talk to the public well?
Talking to friends and even students in the lab and trying to learn to explain things initially in a very easy way. And then it's by looking at their facial expressions, you can tell whether they're understanding it or not. And if they're not, back off and give some analogy or take a little different pathway to try to help them understand what I'm trying to convey. So I think it's just a matter of doing it.
Practice.
It's practice, yeah.
Okay. And just something you set out to do? Was this a goal you set, or it just emerged over time?
It just emerged, yeah.
Okay, cool.
Although now that I'm retired from NIA, so I'm kind of semi-retired. I'm still involved with working with clinicians at Hopkins doing trials of intermittent fasting in various patient populations. And I'm writing a book, finally. 2 books, actually. The first is going to be kind of with an intermittent fasting theme and a historical perspective and a lot of hardcore science, hopefully explained in a way people can understand. And then the second book's going to be pure neuroscience, which is the one I'm really excited about. It's going to be something like thought patterns, how the brain understands and escapes reality.
Okay, that is going to be fascinating. In fact, when you write that book, we'll have you on. A big part of my understanding of the world is really, it's the challenge of not believing your own story so you can see what's really going on, including around food, right? The story in your head is, if I don't have lunch, I'm going to die. And it's probably not really true. Okay.
We wouldn't be here, would we?
Exactly. But man, it sure feels true at the time. And that's, the challenge of fasting in a nutshell is how do you feel good when you do that? Well, let's get in on fasting and just go in for people who, all right, we've heard about fasting. You have pictures of, people in robes fasting for days on end and things like that. Talk to me about the difference between calorie restriction and actual fasting and what you've learned about that over the course of your career.
The differences have to do with the frequency of food intake. A typical human liver can store about 700 calories worth of glucose in the form of glycogen. And if you're just kind of moderate activity, or like we are now, it takes 10, 12 hours to use up those 700 calories. And then when those calories go, then you start using fats. The fatty acids are released, and those are the precursors of the ketones. And so it's possible to reduce your daily calorie intake, but eat, as you mentioned in your introduction, eat meals frequently. Every time you eat a meal, you replenish the glucose stores in your liver, and so your fats are never mobilized, your ketones never go up. So fasting, by definition, if you're in a fasted ketogenic state, that's a sufficient time period with not eating to be designated as fasting. If your ketones never go up, you haven't hit a fasting state.
Okay. What do you do? You've been studying this stuff for a long time. What do you do when you wake up in the morning? Like, what's a typical day for you? What's a typical week?
I never eat breakfast, and I usually try to work out midday or early afternoon.
Yep.
I used to run a lot, do a lot of trail running. I had some knee osteoarthritis because I had a meniscus tear probably. Yeah. But so now I'm mountain biking. Maybe 2 or 3 days a week I'm on the trails on mountain bike. The other days I usually just do some walking or stationary bike. But I pretty much always do that before I eat, around midday, early afternoon, and then I eat all my food within usually a 6-hour time window, sometimes 5 hours. So that the rationale for exercising at the end of the fasting period it's pretty simple. You get an extra boost in the ketogenic state, but there's also a number of we call pathways or signaling mechanisms that are activated by exercise, both exercise and fasting, to get an amplification of those pathways.
Is this Mtor you're talking about?
Well, yeah, that's one. So, and autophagy.
Okay. Some of my favorite words. Can you define them for people who don't know what they are? Mtor and autophagy.
Okay, and this again relates to the notion of the metabolic switch from glucose to ketones and what happens then. So when your glucose levels are high normal, or particularly after eating a meal, there's a pathway called the Mtor pathway in cells that it is activated. And that pathway stimulates the uptake of the glucose. It also stimulates the uptake of amino acids from proteins in your diet. And then the cells increase their protein synthesis, and they're in kind of a growth state. However, while they're in the growth state, they're also accumulating molecular garbage. So when cells are in a growth state and your glucose protein levels are up in your blood, it can help the cells grow. But if that stays chronically on, there's accumulation of molecules damaged by free radicals, dysfunctional mitochondria.
Yeah.
Those damaged molecules are normally removed from the cells by a process called autophagy. It's the cell's garbage disposal.
And in fact, we just had a recent interview on metabolic autophagy that was very well received. And it's a very important thing, like getting rid of the garbage. And you're saying that if you do an intermittent fast and then exercise at the end of it, you're going to turn up autophagy and you're going to turn up Mtor, which allows you to take amino acids and put it into the cells, or no? Because those don't go at the same time, right?
So no, they go in opposite. So during the fasting and exercise, Mtor pathway is inhibited. The cells go into a stress resistance mode, and they're trying to conserve energy molecules, recycle proteins. So autophagy, it's a garbage disposal, but it's also a recycling bin.
So you can incinerate garbage to make energy.
To make energy, but also to break down damaged proteins, but then take the amino acids from those proteins that are not damaged and use them to make new proteins.
Okay. And you get this from fasting.
And exercise both. Okay. And when you combine them, you get a further enhancement of the autophagy. Then when you eat and rest, then what happens is the cells have cleaned out the garbage. And then when you eat and rest, the Mtor pathway is active. The cells synthesize a lot of new proteins, and they can grow. For example, your muscle cells, when you exercise regularly, your muscle cells don't get bigger during the exercise. They get physically bigger during the rest period. So
it's about recovery.
Right. But if you don't exercise, the cells never get signals that enhance their ability to grow when you do rest. So these cycles of metabolic challenge, recovery, and the challenges being fasting and exercise, and then eating and resting, sleeping is very important. Those intermittent challenges, we think, can optimize health.
Well, here's another question, and you may have gone into this in some of your prodigious research. I will admit I haven't read all of it. When I wrote the Bulletproof Diet, I was looking for things that would suppress Mtor, so it would bound back more strongly. And the three things I found were certainly exercise, which you talked about, fasting, which you talked about, but there was also studies on coffee and Mtor. Have you looked at the effect of coffee on either autophagy or Mtor?
We haven't, and it's a good question that I don't know the answer to. There's a lot of excitement from it's actually a drug development standpoint in rapamycin, and I'm sure you've heard about that.
Yes.
But that's a little bit scary because you can inhibit Mtor too much, and if you inhibit it too much too long, that's not good either. So again, these cycles of, but as far as caffeine goes, my opinion is it's good for your cells, but probably not if you have caffeine levels high 24/7.
Yeah, that whole sleep thing.
I think what most people do, then, drinking coffee or tea in the morning while fasting is a good idea. That caffeine certainly boosts your alertness and enhances your cognition.
And your ketones, right? Cunane's work at UC San Diego showed a ketone boost from it.
Yep.
Okay.
So I think caffeine's good. I published an article in Scientific American in 2015, and the whole take-home message of the article was that many of the chemicals that are in fruits, vegetables, tea, coffee, plants that are good for our health, the actual reason they're in the plants, the evolutionary reason, is that they are noxious agents. They're toxins.
Right.
And caffeine's a good example. If you take pure caffeine and put it on your tongue, you wouldn't want to eat it. It's very bitter tasting. Caffeine's a natural pesticide produced by coffee beans and tea leaves. And if you take coffee beans or tea leaves and put them on your counter and put most any food next to it, and there's ants in your house, the ants will avoid the coffee beans and the tea, and they'll go for the other things that don't have the bitter tasting chemicals in them.
It's fascinating. Nicotine's that way too. And I mean, caffeine and nicotine are two of the smartest drugs from nature that increase human cognitive performance, and they're both kill bugs, which doesn't mean they're bad for us, although nicotine in high doses from any mechanism is.
What's interesting here, Dave, is that some of those chemicals activate the exact same responses in cells that are activated by fasting and exercise.
Wow.
And one of those pathways, which I'm sure you've heard of, is the NRF2 ARE pathway. It's, for example, there's a chemical sulforaphane that's present in high levels in broccoli and
sprouts,
green leafy vegetables. But the key thing of this pathway is it's an antioxidant defense pathway. So when this NRF2 ARE pathway is activated by exercise, fasting, some chemicals in plants, then cells boost their intrinsic antioxidant defenses and are more resistant to being damaged by free radicals. And this is really why the trials of like vitamin E, vitamin A, vitamin C, and a lot of different diseases, cancers, etc., pretty much uniformly failed. What you don't want to swamp your cells continuously with these chemicals that scavenge the free radicals, because then the pathways such as the NRF2 pathway are never activated.
Yeah.
Because they're activated by the stress of the fasting, the exercise, or the chemical.
It's interesting that free radicals themselves are signaling molecules. And I interviewed Dr. Rowan, and then later, how can I blank on his name? That's really strange. I must need more ketones because I don't lose names that often. It's trying at tip of my brain. Anyhow, one of the preeminent ozone therapy guys who looked at the ability of the free radicals from ozone as a signaling molecule to trigger mitochondrial repair, not from breathing ozone, but from other medical uses of it, even just topical on the skin and things like that. And it's really interesting. If you take those antioxidants you talked about before exercise, you don't get the benefits of the exercise.
That's right.
What about during fasting? I mean, should this mean when you're in a fasted state, don't take your vitamin E?
No one, as far as I know, and I know this field pretty well. No one's done those experiments with fasting. It's only with exercise.
All right. Okay, somebody listening is going to do those experiments because all the right people are listening. At least I'm going to tell myself that. So this is a fascinating thing. If you're working on your Ph.D., you're trying to figure out what to do. You're going to go to school. Seriously, investigate this. Just do fasted mice or whatever animals you like working with, or humans. My favorite, guinea pigs. And see what happens if you fast and just look at all the different markers of metabolism, maybe urine organic acids, and see what happens if someone takes a fistful of vitamin E, vitamin C, even glutathione, which I'm a huge fan of. Use that during a fast versus after a fast versus after exercise. We already know what it does to exercise, but if fasting and exercise are kind of mimics of each other, I'll bet you that you should take your antioxidants a while after the fast, not during the fast, or maybe at the beginning. But somebody tell me the answer so I can write about it and I can do it. If you had to bet what the answer would be, what would you bet?
I would bet it'd be similar to exercise. Yeah.
Okay.
Yeah.
Interesting. I've never thought of this before, but I would agree with you that I'd place my bet in that same spot. That said, all right, let's look at that. Now, would you consider there's many different polyphenols, but I mean, I make a polyphenol blend. There's chocolate polyphenols, there's coffee polyphenols, there's oregano, and pretty much any kind of flavorful vegetable, fruit kind of thing, or herb especially. Would you look at avoiding those during an intermittent fast, or would you consider those to be useful during an intermittent fast?
Those the noxious, the bitter tasting ones are probably useful.
Yeah.
Yeah.
I think so too. I don't know any delicious polyphenols off the top of my head. They're all pretty nasty tasting. Other than it turns out people who are fast caffeine metabolizers, they don't taste caffeine as bitter as people who are slow caffeine metabolizers, which is really interesting. Yeah. So there's some sort of little subcellular mechanism that's like, you should get more of this. But okay, so I'm going to keep doing that in the morning. Okay, this is a great question. There are lots of studies on mice done with water-only fasting. And so there are people out there who say, oh, well, they just had water, so you should only have water. But all the stuff I know, even like traditional Chinese medicine, they at least had tea or coffee or, pine bark tea or whatever the heck, depending on where you're from. So I always say, look, when you're intermittent fasting, have your coffee, have your tea, enjoy your life. But the purists are like, oh, we don't know what it does to your gut bacteria. Where are you on the spectrum of you should only do what the mice did versus have a little fun?
I think it's actually a good idea, at least from the standpoint of the brain, to drink tea or coffee
during a fast.
Yeah.
All right, and you'd be fine with an herbal tea as well, then. Yeah. Okay, got it. And there's all sorts of different herbal teas you can do. What about mushrooms? Medicinal mushroom kind of teas, and people love. I don't like chaga very much at all, but I've really gotten some benefits from the lion's mane. I just had the Life Cycle guys on about that, and I just had Paul Stamets on, who's famous mushroom guy. Yeah. Is there and I loved Paul. He was so cool. Is there anything that you've come across on using mushroom extracts, not actually eating them because that'd be calories, during fasting?
No studies. I am interested in mushrooms. Last few years I started foraging. I've got Paul's big, thick
mycelium
book.
running. I think I've got it right back there.
Yeah, and I actually bought some mice. What did I get? Oyster and shiitake mycelia from his company in the spring, and they're out in the wood chips right now.
Oh, beautiful.
Yeah.
I'm just starting commercially growing cordyceps on my farm here in BC, which is really cool.
Oh, nice. Yeah. And Paul's he's from your neck of the woods.
Yeah, he's one island over. Yeah. He came out for the interview. It was fantastic. Sounds like you guys know each other.
I don't know him, but fascinating chemicals in mushrooms. A lot more work needs to be done. There are some reasonable studies with things like turkey tail tea and some of the things Paul talked about. But on the other hand, it's an area where there's a big need for a lot of better science. As you know, finally they're starting to do studies now with hallucinogenic mushrooms. One of the scientists at Hopkins, in fact, has shown in a couple published studies now that the psilocybin mushrooms are beneficial in people with depression, and and they're not addictive. In contrast to the opioids, right, which is a huge problem. These chemicals in mushrooms that seem to have some interesting effects on the nervous system are not addictive. which would seem to be a big advantage.
It seems nonsensical that alcohol, nicotine, and the opiates are legal and cause a lot of harm, but I don't know how anyone could be really addicted to the strong hallucinogens. There are people who dissociate because they're so traumatized, but it's not an addiction. That's a just deep-seated trauma response, which is a different animal. At least that's my wife says so, and she's a Karolinska trained drug and alcohol addiction emergency doctor. So I'm gonna believe her there when she says there are people who abuse them, but they're not addicted, versus the actual addiction.
Yeah.
So. All right. I'm really interested in compounds that I know that you're interested in: nerve growth factor, NGF, and Bdnf, brain-derived nootropic factor. And I wrote about those in Headstrong, and I've used. There's old studies on mushrooms. There's a compound I use in one of my supplements from the fruit of coffee, a polyphenol that raises Bdnf. Coffee itself probably does, according to some other research. Fasting, I believe, raises Bdnf. Can you walk through your perspective on increasing nerve growth factor and brain-derived nootropic factor? What do you believe works, and how important is it for living a long time with a good brain?
Well, both Bdnf and NGF are important for the development of the nervous system, for the survival, growth, synapse formation, and then the fine-tuning of the structure of the brain during development. If you eliminate the genes of either NGF or Bdnf from mice, they die during development, so they're critical. In the adult brain, Bdnf is particularly important throughout the brain, all over the brain, in promoting the growth, survival of neurons. It's critical for learning and memory. And it's also, we showed in my lab when I was back at the University of Kentucky in the early 1990s that Bdnf protects nerve cells against various types of stress: oxidative stress, metabolic stress, something we call excitotoxic stress, which is unconstrained neural network activity, like occurs dramatically in epilepsy, but we think to less dramatic extent in brain aging and Alzheimer's disease. So NGF, on the other hand, there are only a small but important group of brain cells that are responsive to Bdnf in the adult brain. Exercise is a potent stimulator of Bdnf production in the brain. Intermittent fasting stimulates Bdnf production, and the combination of exercise and fasting get an additive effect in boosting Bdnf. And I had a graduate student, Alexis Stranahan, who showed that many years ago in studies where she combined running wheel exercise and daily time-restricted feeding, daily short fast, and found she got additive effect in increasing Bdnf and in actually protecting synapses against diabetes, which is kind of another angle on this. It turns out that obesity and diabetes are not only bad for your heart, they're bad for your brain, particularly as you get older. And we think that intermittent fasting, well, we actually know it. Yeah. Intermittent fasting and exercise can reverse diabetes and obesity in humans if a person can switch their eating pattern and get on an exercise program. And Bdnf plays a role in that. So in individuals who are obese or diabetic, Bdnf levels are lower in their brains compared to normal weight, metabolically healthy people.
One of the things that really changed my life when I weighed 300 pounds and I was having all kinds of cognitive dysfunction in my 20s and early 30s, I started using a thing they called the Russian sleep machine, a cerebral electrical stimulation with alternating current between the ears. Very different than the TDCS we use now. And it turns out there are studies that show both TDCS and CES or alternating current raise BDNF very meaningfully.
Oh, that's interesting. Yeah.
I'd go to sleep with this thing, and I swear my brain helped to turn back on. And now at 40 years of Zen, the brain upgrade place that I started, we use a clinical grade, neuroscience level system that lets you have specific frequencies that are tunable and controllable by a computer. And we do that to prime the brain for better learning of altered states that you learn through neurofeedback. And you go all the way down to companies like Halo, who's been on the show, who makes a TDCS headset. When I do exercise, I especially lately, I can't keep up very well with my 9-year-old at ping pong. Okay, and ping pong is a high reaction time thing. It keeps your brain young. Dr. Amen told me to buy the ping pong table. I did. So I started saying, all right, I need some more BDNF here. Like my son's kicking my butt. And we've got the pro-grade, carbon fiber paddles, and we're going at it. Like he's good. Either that or I'm bad. But I was not a good competitor for him. So I started running the electrical current over my brain again, using the Halo. And all of a sudden my learning went up. And like 20 minutes after doing it, it's like the ball slows down and I can hit it. And so I believe that's a BDNF sort of thing. But have you seen electrical stimulation, magnets, lights, going to the bottom of swimming pools? I don't know, any other crazy tech like that that's going to make our brains more plastic?
The answer is yes. And first I want to go back to when you were young and obese, right? And you did this alternating current stimulation of your brain. Did that reduce your appetite? The reason I ask is it turns out that BDNF suppresses appetite.
Interesting.
This is
I don't think it did. I'm going back to all the different times I'd use it. I would oftentimes use it when I was sleeping, or like when I wanted to write, even when I was writing, actually all my books, there were times where I'd change the frequency on my device to go up into the gamma ranges.
Did it help you lose weight?
It could have. I feel like the thing that really helped me lose weight was getting rid of the inflammatory foods. Things that were inhibiting mitochondrial function was the number one thing. Yeah. But it could have had an impact. But for me, it was, I just went into ketosis. Okay. And then I came out of ketosis and I went in and out. And that got half my weight down. And then the other half was, oh, hey, guess what? Certain foods are going to make you inflamed no matter what. So you got to change the type of fat that makes you go into ketosis. You got to get rid of the nightshades if you're sensitive like I am. And that was the genesis of the whole bulletproof diet approach, which was these foods may or may not be good for you, but don't assume they're all good, because if you're still fat after you tried hard. So for me, it was finding the guilty suspects.
So let's get back to stimulation and BDNF. Yeah. BDNF was discovered in an animal model of epileptic seizures. There was a lab out in California that was just kind of looking for genes that are responsive to epileptic seizures. And BDNF is highly responsive. So as you know, one of the treatments for depression, which is still used in people who don't respond well to antidepressant drugs, is electroconvulsive shock therapy.
Right.
And it's highly antidepressant, and it's highly potent in inducing BDNF expression.
Wow, I didn't know that.
Also, the antidepressant drugs themselves, the serotonin and norepinephrine reuptake inhibitors, Prozac, Paxil, etc., they increase BDNF levels in the brain. And in animal studies, we have ways we can genetically manipulate the mice so that they can't respond to BDNF. Those mice do not show an antidepressant response to those drugs. So altogether, the available evidence says BDNF it's an antidepressant, endogenous antidepressant. I mentioned it's potently upregulated by exercise. Exercise is a really good antidepressant. And in fact, there may people who exercise regularly and then have some injury and they stop exercising. That can often precipitate an episode of depression. because they've been going along exercising, and all of a sudden, probably their BDNF levels are going down. So anyway, there is some evidence that even low direct current stimulation or transcranial magnetic stimulation can increase BDNF levels.
Yeah.
Caffeine will increase BDNF levels.
Okay.
There you go.
I'm intrigued about what you do to manage your BDNF levels, and I want to just warn everyone. Look, you're an expert on aging, but you're also the age you are, and you're a male, and you have your genetic and lifestyle factors that we all have. So this isn't a do what you do, but I want to know what you do specifically for BDNF and NGF to keep yourself strong in those things, and then I want to know why you do it. So what's your personal practice for managing those? Do you even measure them? Well,
that's a problem because we'd have to measure them in the brain, or at least the cerebral spinal fluid. So it turns out that there is BDNF and NGF in the blood, but the levels of those trophic factors in the blood in animal studies are not well correlated with levels in the brain. It turns out that nerve cells are not the only cells that produce BDNF. Your heart cells, interestingly, produce BDNF, and there's other cells. But anyway, kind of the bottom line is, unfortunately, unlike ketones, which we can easily measure from a finger stick in blood, we can't measure BDNF or NGF. There's no way non-invasively to do that. So I'm just going by what the animal studies say.
Sure.
So again, my normal routine is don't eat breakfast, drink a lot of green tea in the morning. Don't drink green tea a couple hours before I exercise, which I said is around midday, say 1 o'clock.
Okay.
Because I found I can get some gastric reflux actually if I drink tea right before I exercise. But then anyway, so then I exercise in the fasted state. My diet during the 6-hour time window I eat is what most people would consider a variety of healthy foods: vegetables, fruits, a lot of nuts, yogurt. If I eat meat, it's usually fish, occasionally chicken, but not so much. Whole grains, there's a lot of literature out there on whole grains one way and the other, and there are people who are sensitive to gluten and so on, but my take on the scientific literature is that whole grains are generally good for health.
So you eat whole grains?
I eat whole grains.
How do you stay in ketosis if you eat whole grains and fruit?
Well, I go into ketosis in the morning.
There you go. I was hoping you were going to say that.
Yeah.
We'll probably agree to disagree on whole grains for the average person, but some people tolerate them really well. I know they completely shred other people over time. So those are in the suspect
But Dave,
foods thing.
Well, I don't know. So refined grains are not good, but the whole grains have a lot of fiber, which was good for your gut microbiota.
Unquestionably.
And if you look at the actual scientific studies, there's epidemiological evidence that whole grains are good. Even in the blue zones, which most of your listeners will be familiar with, regions in the world where people, usually large number of people live to be 100. Several of those areas, a lot of the calories are in whole grains, whether it's rice in the Okinawa diet and so on.
But are the Okinawans eating white rice or brown rice? It's white.
Yeah, it's white.
Yeah, it's not a whole grain. They got rid of the lectins from the outside and all the phytic acid and all the other stuff.
But there you go. But they have a low calorie diet, and one thing that hasn't been studied a lot in them, as far as I know, is as far as I know, no one's measured their ketone levels. So.
Oh, interesting. Wouldn't that be fun?
Yeah. So it would be interesting in these blue zone people to look, take blood at different time points throughout the 24-hour period with their eating pattern. They're not all eating 3 meals a day, spaced regularly.
Yeah.
So I think whether they're having the metabolic switching occurring would be an important thing to know, because we think that's much more important than diet composition, except
Yes.
Except for it's definitely good to avoid simple sugars. It's definitely good to avoid a lot of saturated fats. But the whole...
What about fried polyunsaturated fats that were never in our diet either? Those seem worse than saturated.
Well, no, the trans fats are worse.
Yeah, or even just heated, the stuff that your French fries are made in.
yeah, that's bad.
Okay, so I'm following what you're saying, but I'm a little bit so on your overall sort of daily thing. You're eating a moderate amount of carbs. It sounds like you're not going hog wild on the carbs. You're avoiding simple sugars in the afternoon, evening, and in the morning you're eating nothing, so you can stay in that fasted state. We also talk about ketones, and because you've developed this metabolic flexibility, when you measure ketones in the morning, where are they?
The ketone strips that you can buy commercially to measure ketone levels, they're only sensitive down to around 300 micromolar. Below that, you can't tell right? And it turns out there's two phases of ketone production that occur. As soon as the glycogen stores in the liver are depleted, you get an increase from way down, low micromolar levels, up to about 300 micromolar. And they stay up in that level for like between 10 up to 24 hours. And then there's a second bigger increase in ketones where they go up into the millimolar levels.
And that's over what time frame was the second spike?
Beginning about 24 hours of complete fasting.
Okay.
So my ketone levels, in the late morning, they get up around the 300 micromolar level. And then actually, I haven't measured them after exercise. I should.
Yeah.
But I'm expecting they'll go up, getting closer to the 1 millimolar level or above during the exercise. So I think a lot of people will find that if they use the ketone strips, even after 12, even 16 hours of fasting, they may look and say, my ketones aren't up at all, but probably they are up. It's just below the lower limit of detection of those ketone strips.
And if you use a finger stick, you can get the 0.1 level, right?
Not if you're using the paper strips to measure.
No, I mean there's the P strips and then there's the finger stick strips. What are you talking? Which strip are you talking about?
Either strip.
Oh, interesting. Even the finger stick.
Yeah, you have to use other methods that are more sensitive. That there are commercially available, but they're from scientific.
They're pricey.
They're pricey.
Okay, that makes a lot of sense. In my research and just my own experience, if I do brain octane, the one of the 4 kinds of MCT that actually after I noticed the difference, the studies came out and showed that it raises ketones more than other MCTs or short or long chain fats, or at least probably butyric acid raises it as much. But anyway, it's the most powerful MCT, whatever. I put that in my Bulletproof coffee. I can have donuts for dinner. Not that I actually eat donuts, but I can have however many carbs I want. More like probably sushi with white rice. Wake up in the morning. I can have my Bulletproof coffee, and I can get to 0.5 on a finger strip.
Yeah.
Right. And it seems like there's
good. Yep.
In mice, there's things that happen with CCK and ghrelin at 0.3 and 0.5. And those seem like, to me, the kind of the magic levels where I don't care about food anymore and good stuff happens metabolically. But you're like the godfather of intermittent fasting here. So am I reading too much into the mice studies and my own experiences there, or are those special levels, or is 0.7 better, or like what are the levels?
Oh, well, I guess my point in this biphasic, an initial small, relatively small, but physiologically and probably health beneficial, this lower level like you're talking about, 0.5 millimolar. My view, based on the animal studies and human studies and the time course that we know that ketones change, those early increases in ketones are important for improving health, and including improving cognition and suppressing appetite, which ketones do. Now your bulletproof MCTs, they're 5-6 carbon length.
No, they're
length, or what,
the 8 carbon. The 6
8,
carbons, unfortunately, they might be slightly more ketogenic. They taste terrible, and they're huge gastric irritants. So one of the problems with a lot of MCTs, those aren't adequately filtered out. You get a little bit of those or some C17s, and then you get that burning throat or the real strong disaster pants. And I managed to engineer around that in the early days of Bulletproof. So that's not the issue it once was. You know what I'm talking about from MCTs.
Yeah.
So it's the 8s, and that's later Cunnane came along and said, oh, look, 4 times more ketones than actually what you get from coconut oil.
Yeah, Steve Cunnane has done some. So we did work with the ketone ester in an animal model of Alzheimer's disease collaborated with Richard Veach. He sent a postdoc up to my lab, and we did the experiments with our mouse model of Alzheimer's. And then, so we published that in 2013. And then, as you know, Steve is using PET imaging, positron emission tomography, using radio-labeled acetoacetate, which is one of the 2 main ketones, the elevated during fasting and extended exercise, the other being beta-hydroxybutyrate. But so he could look at the brains of humans and see how are the brain cells using the ketones for energy, or are they using glucose for energy? And he takes these humans, puts them on a ketogenic diet, and they switch from using glucose to ketones. It's dramatic. We think Alzheimer's, we know the nerve cells in the brains of Alzheimer's patients, the nerve cells that are still alive, they have a big problem using glucose.
Yes.
But we're pretty sure they can still use ketones.
You're talking about the neurons specifically.
Yeah, in people with Alzheimer's. So if people with Alzheimer's are eating carbohydrates and their ketones are low and their nerve cells cannot use the glucose very well and the ketone levels are low, the nerve cells' ATP levels are low. However, if the Alzheimer's patients can increase their ketone levels, in the mice models we know that, and the humans we think, at least based on the science, it's likely that they can still use the ketones. And so Steve is involved in the initial stages of a trial of the ketone ester in Alzheimer's patients. He already gave patients with mild cognitive impairment MCTs.
Oh yeah.
Which was it your MCTs or was it?
Yes, as far as I understand. He's run multiple studies, but some of his studies are using specifically our MCTs, but I don't know if that was the study that was using ours.
Right. And so as you know, he's already published a paper in patients with mild cognitive impairment, which is often a precursor to Alzheimer's. That is to say, people with short-term memory problems that are diagnosed with mild cognitive impairment, they're at increased risk for going on to develop frank Alzheimer's. So that's, this is exciting news. There's no treatments for MCI or Alzheimer's. We know exercise helps in MCI patients.
Doesn't hyperbaric also help them?
Hyperbaric? Or
hyperbaric.
I don't know. I think that would be not a good thing. This whole hormesis idea, then, so if you increase oxygen levels, then the antioxidant defense pathways are toned down, like the NRF2 pathway. Whereas mild hypoxia, which is what occurs during exercise, that ramps up these intrinsic defense mechanisms. So
it's interesting. I interviewed Dr. Hart, who wrote The Oxygen Advantage and is probably one of the preeminent hyperbaric guys. We talked about that. No, I understand there's 2 sides to the coin, but the reason it's interesting is that some of the other training that we do at Upgrade Labs, stuff I have right downstairs, is intermittent hypoxic training, where you're actually on an exercise bike breathing air that has no oxygen to drop your blood oxygen down to 87% to cause a hormetic reaction so your hemoglobin can let go of oxygen more easily later. And it seems like, just like with food, you're fasting sometimes, there's no damn food. And sometimes there's only ketones, and sometimes there's glucose. And it seems like maybe for temperature, sometimes it's really hot, I'm in a sauna. Sometimes it's really cold, I'm in cryotherapy. And then for oxygen, sometimes there's no air, and sometimes there's tons of air. It seems like teaching the body to
adapt,
survive and thrive in short-term extremes is a good strategy for living a long time and feeling good.
Yeah. You know, we did multiple studies looking at the effects of alternate day fasting in rats on heart rate and blood pressure.
Oh, wow. What'd you find?
It's very dramatic, and it's very similar to what's seen with endurance athletes. Not immediately. It takes 2 weeks to a month, and by then it's very clear. The animals on alternate day fasting, their resting heart rate and blood pressure decrease. Their heart rate variability increases.
Which is a very good thing.
It's a good thing. It's what you see in endurance athletes. What's happening is, we found by measuring these things, the alternate day fasting, similar to endurance training, increases the activity in the parasympathetic nervous system. Your heart rate is controlled, and blood pressure, by a balance and shifting between parasympathetic and sympathetic nervous system. Your parasympathetic nervous system slows heart rate, reduces blood pressure. Your sympathetic nervous system increases heart rate and blood pressure. And so what's happening with the intermittent fasting is that your heart becomes more adaptable to shifts in load levels. For example, we did stress tests in the animals. We subject them to a very stressful situation where essentially we put them in a straitjacket where they can't move.
Okay.
And so that will cause a big activation of the sympathetic nervous system, the flight or fight response. Their heart rate will go way up. But in the animals that have adapted to alternate day fasting, their heart rate initially goes up when they're under this stressful situation, but then it comes down more quickly after they adapt. So they adapt more to the stressful situation when they're adapted to intermittent fasting.
So resilience goes up.
Yep.
Cool. Well, let's switch gears a bit. We know what you eat. We know how you exercise. And how about rapamycin? Have you ever taken it?
No.
How about the other anti-aging stuff? Growth hormone, testosterone, supplements. I mean, you're a head anti-aging guy. You study all this stuff. You don't use any of it?
The only thing I'm taking now is curcumin.
Okay.
Because I got some knee osteoarthritis. And vitamin D and folic acid. That's it. I mentioned I eat a variety of vegetables, fruits, nuts, and so on. Sure. And so on. And, you know, the studies we've done in animals and others manipulating specific nutrients, and the NIA's lifespan studies, compared to daily calorie restriction or intermittent fasting, none of those things have nearly as powerful effects. So that's what I'm basing it on.
I got to agree with you there. Quality sleep and some intermittent fasting and moderate exercise, not even crazy exercise, are ginormous variables. And it does seem, though, I mean, James Clements came on and we talked a lot about increasing autophagy, including pharmaceutical stuff, Aubrey de Grey, the different 7 different pillars of aging. It feels like we are making progress on there. David Sinclair's coming on, this NAD pathways on mitochondrial repair. I mean, it feels like this brave new world of anti-aging tech. It's all just coming online now, or am I just a hopeless optimist?
That rapamycin is very interesting. The NIA has supported a 3-center study of lifespan studies where various people propose things to try: metformin, rapamycin, sulforaphane, et cetera. And they've completed studies with 30-some different test chemicals, and rapamycin is the only one that caused clear, highly statistically significant increase in average lifespan in the mice in all 3 studies. So in the animals, it's convincing that rapamycin can increase lifespan. It's the only single chemical intervention that's been clearly shown to increase lifespan. But
what about metformin? I mean, that's another one, right?
In the 3-center, there's some published studies suggesting it increases lifespan, but in the 3-center study, where all 3 centers they did metformin identically over 100 mice each study. They didn't see a statistical significant effect.
I am completely flummoxed by metformin. I mean, I started taking it many years ago, and the first studies came out from biomarker pharmaceuticals. And then I quit because of the B12 and mitochondrial harm things and switched to an herb for AMP-K. And then I talked to James Clements recently. He said, "Oh, that herb isn't so good either." And so I go back and forth. Most of the anti-aging clinicians I know are using it in their practice and seeing positive benefits, even if it isn't life extending. There's certainly quality of life, performance, and the labs look better. But I'm torn on that one.
Yeah, the glucose regulations improved certainly.
But you mostly don't do any of that stuff. You're like, I don't eat for a while, and I get some sleep and I get some exercise at the right time, which is at the end of a fast, and you're pretty much good to go with that.
Yeah.
All right.
And as far as I know, the people in the blue zones aren't taking any metformin or rapamycin or any of these other things. They're saving their money and still living to be 100, and it's diet and lifestyle. Yeah.
That is true. At the same time, they also live in the blue zones, which says if you don't live in a blue zone and you live in a highly polluted city, you might want to change what you do to match the environment, right?
Yeah.
I mean, there's a bunch of theories. There's glacial melt water with extra minerals in it. There's, all kinds of stuff around, deuterium depleted. There's some fringe theories around that. There's, lifestyle stress, and, the diets are all over the place from 70% fat to 70% carbs. And I'm having a hard time using epidemiology to get anything useful.
Yeah, I don't like epidemiology either because
So we're kind of in agreement on that. I want to know how it works, and I want to say if you do X, you reliably get Y, and then I'm going to do X even if I'm not a mouse and see if I get Y, and if so, I'm just going to have to deal with that because it's better than what I had before, which was random in and random out. But that offends some academics because it's I'm N = 1 and I might be biased. I'm like, yeah, I'm biased, but I feel good. So how do you sort that out? I mean, I talked to Dr. Newhouse, who wrote the first paper in 1988 on nicotine for Alzheimer's from Vanderbilt. And he's like, I've never used nicotine. I'm like, how can you study something for 30 years without taking a little hit of it once? Right.
Well, I do intermittent fasting, right?
Okay,
and
that's what I started by. Fair point. And so that's your number one intervention, and you do it. All right, so I'll give you that. Okay. The ways to raise ketones externally. There's MCT oils, and different ones do different things. There's ketone salts, and different ones do different things. And Dr. Veach raised the bioidentical issue there. I actually had a ketone salt product ready to ship, and I canceled it because I'm not selling something that might feel good but cause harm later. But there are people who are advocates of them, especially short-term use and things like that. And then there's the esters, which Dr. Veach and I talked about, you talked about, and I actually synthesized some 6 years ago, but they're $40,000 a kilo. I couldn't commercialize them. And there's still $100 for 3 doses, kind of things for people to do it. Is there a risk? Let me put it another way. There is a risk with blood sugar. If your blood sugar levels are high, it doesn't mean that you have more energy and you've done a good thing. It means you're not metabolizing blood sugar. If your ketone levels are exceptionally high, is there any sort of a similar situation where, hey, they're high because you can't metabolize them, right? You're going to drain them as fast as you can? Or should we not worry about, my ketone levels are higher than your ketone levels, sort of things?
Yeah, this is a good question. We know that with long-term fasts of weeks or even months, or do we know? Yeah, we assume that it's important. It's important that the ketones be high because the cells are using the ketones for energy. But as far as exogenously elevating ketones with MCTs or ketone ester, long-term, chronically, we don't know. My current thinking is intermittent elevations may be better than continuous. And, the cycling between activating mTOR and inhibiting it, upregulating autophagy, then going into a growth mode, that switching back and forth is important. And as much as the ketones play roles in that, and in fact, we showed ketones can stimulate Bdnf production.
Oh, wow.
But however, this is very interesting. It turns out that Bdnf is normally produced by neurons in an activity-dependent manner. That is, it's produced when a neuron is electrically active. And so it's produced when and where it's needed. And we found if we swamp neurons with Bdnf continuously, it's actually bad for them.
Oh, interesting.
And we did this in a published study where we were looking at the autonomic nervous system. Remember, I said that intermittent fasting increases parasympathetic activity and reduces heart rate. So, and we had evidence there was a role for Bdnf in that. But it gets a little complicated. But the parasympathetic neurons that send their axons to the heart, the neurons themselves are located in the brainstem. They use acetylcholine as a neurotransmitter. And so Bdnf, if we transiently apply Bdnf to those neurons, they produce more acetylcholine, heart rate goes down. However, if we continuously swamp those neurons with Bdnf, then they deplete the acetylcholine and the heart rate actually goes up. So my point is, your systems are very intricate and are producing things where and when they're needed, and it may not be good to continuously swamp the system. So we don't know for sure with ketones, but my intuition says maybe it's not such a good idea to just have ketones up 24/7 chronically.
I'd say the jury's out on it. I've gone from using brain octane just in my morning coffee to I pretty much put it on every meal, but my ketone levels are generally not above 0.3 except in the morning. So I think they're higher than physiological, but they're not high. And what I feel like that does is that affects my ghrelin levels. So I'm just not hungry. And so I can go long times without food. My brain, it just feels effortless. And we know that your neurons will use ketones even in the presence of glucose because of the studies you talked about earlier. But the glial cells, the repair cells in the brain, and I know I'm simplifying what glial cells do there, but they like glucose more than ketones, right? So that's why I'm really concerned about the keto bro diets out there where, if you eat another carb again, you're a bad human being kind of thing, because it feels like there's a role for carbs.
I think there is too, Dave. Yeah. And, there was a recently published study. It suggests the paleo diet's not good long term. I don't think it's a good idea just to eat only fats and protein. In fact, too much protein is definitely bad from the standpoint of aging.
Oh yeah, the paleo diet is they're burned protein and way too much protein. In fact, my new anti-aging book that's coming out soon, I read a lot about protein restriction. In fact, there's 1 day a week of protein fasting was part of the original Bulletproof diet because it increases autophagy. You'd have less than 15 grams. But for you, what kind of protein is worse and what kind is best?
Well, usually in animal meats, you've got a mixture of fats and protein. And so the fish story is strong. You can't go wrong eating fish.
Yeah.
Ideally, some of the smaller fish with regard to the mercury issue. But, red meat, you don't need it at all. You get plenty of protein. Everything's all goofed up. Our parents told us you don't get any dessert, which is sugar, unless you finish your meal, right? So eat a lot, overeat, and then you can have your sugar.
Yeah.
And
so you overeat.
You got to eat your meat, drink your milk to get protein. So kids are getting too much protein. The mTOR pathway is overactivated. Their cells aren't removing the garbage.
Right.
And in fact, the huge problem that's hard to tackle is how to change the family environment. Kids' habits, their eating habits, whether or not they exercise throughout their life, for many people, it's determined by what their parents are doing.
At what age should you start intermittent fasting your kids?
I can't make a definitive statement on that.
If you had to bet, what would you bet?
Once they're sexually mature.
Okay, so basically after puberty.
Yeah.
Yeah, that's generally what I'm doing. I don't intermittent fast my kids. We're probably going to do once a month where we do a 24-hour fast with the kids, just so they can see that we do it, and so they can toughen up a little bit. And like, you're not going to die if you don't have it. And I've used intermittent fasting as a threat. When they say I'm not going to eat my broccoli, I'm like, oh, you've chosen intermittent fast with me. Let's all put our food away, and then they eat their broccoli, and like the conversation's over. But it feels like it would not be a good thing to do that to a metabolism of a growing child, but we don't know. It might be fantastic.
Yeah. And if you go up from an evolutionary perspective again, certainly kids, infants and young children used to nurse, breast milk a lot longer than they do now.
Yeah.
But on the other hand,
true.
Once they're weaned, they're probably eating intermittently before the agricultural revolution. But I want to make one comment I gave a talk at one of the annual meetings for the American Association for the Advancement of Science, the AAAS, and this woman came up to me after my talk, and she said, "That was a great talk," and she said, "I'm glad I came to your talk. I'm so relieved now because my son, who's in high school, he's not eating breakfast. He hasn't been eating breakfast for a year, and I've been worried about him. He's a straight A student. He's active in sports. He's a really good athlete, but he hasn't eaten breakfast." And so she said, "I'm relieved now because, he's doing well, and I'm not going to worry anymore about whether or not he eats breakfast."
Oh, that's great. I love that. And yeah, just a little bit of metabolic flexibility and different metabolisms need different things at different ages too. So I'll go with you there. Mark, I've got a final question for you, and I'm intrigued at your answer because you have such a deep expertise in things like this. I've been pretty public on my. I'm counting on guys like you and many other friends to expand over the next 100 years or so, expand the maximum human limit so I can reach at least 180. But I'm fully expecting skepticism from you there. My question for you, though, is a little bit more personal. How long do you think you're going to live, given what you know about aging, what your colleagues know, and the tools you have access to? What's feasible for you? What do you think is going to happen assuming a truck doesn't hit you? Yeah,
so my genetics is kind of mixed. Although it's hard to really. So my mom and her siblings. My mom actually died at 67, but she was a 2-pack a day smoker and
that whole epigenetics thing will get you.
And had arthritis and was on prednisone for years and so on and so on. And she got a knee replacement, got sepsis, then had a hemorrhagic stroke. My father lived to be 90.
Okay.
And I'm more like him from the standpoint of my, I guess you'd say, skinny, as is my, my brother and sister are pretty skinny. Our 2 kids are pretty skinny. So, I'd be happy if I made it to 90. I have no, if I made it to 100, that'd be wonderful, but I'm not counting on it.
Don't you think you can do better than your parents? I mean, we know more than your parents did. We have better tools. We have radioactive imaging. We have DNA. We have mitochondria.
So in the animal studies, the biggest impact of the intermittent fasting is on average lifespan.
Mm-hmm. But not total lifespan.
Not maximum, although there's some effects. So then the other thing is health span.
Yeah, that matters more.
Yeah. I'm starting to, I mentioned, get some orthopedic issues now, which is really my only health issues right now.
It's probably a lack of red meat. I mean, that's what your mom said.
Well, she had really bad arthritis too, so I have
right.
at an earlier age. So,
yeah. It does happen.
I think we should think about future generations. Right? Think about your kids.
Okay. What's feasible for future generations?
So maybe how many children?
How about my kids?
Yeah.
How long are my kids going to have a chance of living?
Well, they have a better chance of living longer than you did. Just as I would say, I definitely have a better chance of living longer than the average of my father and mother.
Oh yeah.
We need something new though to extend maximum lifespan for rapamycin. I don't know, maybe, but again, the animal studies. Remember that the control animals that the rapamycin treated group being compared to are overfed sedentary animals.
Okay.
They, and remember that's also the control animals for the intermittent fasting studies. Is the control group has continuous access to food. They're in small cages, don't get much exercise, and a lot of strains of animals, they become obese and even will become insulin resistant as they age. So the animal studies say if we take relatively sedentary, probably overindulgent animals, and we put them on intermittent fasting, combine it with exercise a little, helps a little more, we can increase their lifespan. Rapamycin can increase their lifespan. But what we need to do is start combining, say, intermittent fasting with rapamycin. Can we get a further increase? And I don't know. I'm not sure we will.
Yeah, we definitely don't know until we try it. And I look at the sum total of all the people doing all the research on all the pathways and just the ability to learn things from machine learning. I'm pretty optimistic that my kids are going to live a lot longer than I am. And it feels like the last 30 years of work is now accessible on my iPhone. And it wasn't 25 years ago. We had microfiche.
Yeah.
Like, it's so much easier to, there is a connection there. So I'm hopeful.
Yeah, I wrote my Ph.D. dissertation was on a typewriter using whiteout to correct my typing errors.
The world has changed. Well, I hope the world of anti-aging changes as well. And I am grateful for your contribution around this. And I totally believe you're right. This not eating is one of the key things. That doesn't mean being hungry all the time, but it means not eating some of the time. So I'm grateful that you came on the show. People who are interested in your work, probably the easiest way to find you is Googling Mark Mattson, and you're the first couple of pages of results. And your TED Talk is totally worth watching. And thanks for the decades of work on anti-aging and fasting and neurology. I find it fascinating, and you've done a good thing.
Well, thanks, Dave. I've enjoyed it a lot, and you keep up the good work too. As I said at the beginning of our conversation, there's a big need for translating this basic research into practical things that people can apply to their own lives.
Well, I will keep doing my best. I'll ask the hard questions. And just to reiterate for people listening, I think we're both serious. If someone out there wants to do a Ph.D. or some other kind of research project on antioxidants and intermittent fasting, it's a wide open area that totally needs attention. And I never thought about that until today. So you stimulated a new idea. Thank you.
Okay, Dave.
All right. If you like today's episode, you know what to do. Head on out there and skip breakfast. You'll like your life better if you do that, most likely. And if you hate your life when you skip breakfast, you got to figure out, all right, what's going on with my metabolism? Because I'm probably not as resilient as I'd like to be. And then you can work on that. And if you want to know how to do that, there's a whole variety of episodes of Bulletproof Radio. We talked about a few of them today. Listen to this one again, get the show notes. You could read The Bulletproof Diet. You could read Headstrong. I talk about intermittent fasting in both of those books. And there's just so much knowledge available right now on the blog and in other places. And really, if you don't know what else to do, wake up, skip breakfast. Don't put sugar in your coffee. Don't put artificial sweeteners in it, and see what happens. And you just might be okay.